Algebra Word Problems, number 10A, several possible equations, addition or subtraction. We've been doing word problems, and you know I have a strategy that we have to read the problem. If it's a word problem, we're going to want to underline or circle what's important. We need to make a plan of how we're going to solve it. We need to turn unknown amounts into variables, right? Figure out if we're going to add, subtract, multiply, or divide. We need to write the expression or equation, find the solution, or simplify the expression. We check it by plugging our answer in. And we want to remember that when there's a number in front of a variable, he's a coefficient, or she. The minute this variable goes away, whatever it is, x, y, z, l, m, p, q, whatever, he just becomes a standalone number and he's not a coefficient anymore, okay? So all algebraic equations are solved by using inverse operations. Addition undoes subtraction, subtraction undoes addition. Multiplication will undo division, and division will undo multiplication. So to solve for an unknown variable, we need to remove the same amount from each side of the equal sign. So the variable is alone, it's isolated. We want to think of it as a scale, and we want to keep the weight as the same on each side of the equal sign, so it's balanced. If we have x plus 4 equals 10, we would solve by saying subtract 4 from each side, right? So that would leave us, because these would become 0 pairs, the positive 4 and the negative 4 would become 0 pairs, it would leave us with x equals 6. So any inverse operation done on one side of the equal sign must be exactly the same operation on the other side of the equal sign. So if we subtract 4 from this side, we've got to subtract 4 from that side. We've got to keep it balanced, right? So just remember, maintain our balance. Now if you saw this ad, paper towels for $4.47, regularly $5.49, super absorbent, yay, great sale, okay? Well, we understand that a sale price is less than a regular price. And to find the savings amount, we've got to let x equal the amount of the savings. So there's several possible equations that could be written to find the value of x. We can think of x, the amount of the savings, as an addend and add it to the amount of the sale price, and then we'll get the difference of our regular price. Or we could use our regular price and subtract our unknown amount of savings and get a difference of our sale price. Or we could use the amount of our savings as the difference, as the answer, and it equals the regular price minus the sale price. Now this third one would be what you learned in second or third grade. I want you to keep an open mind about other ways to write an equation, okay? It's going to help you immensely in the future. So if we're looking at number 1, we've got x plus 447 is going to equal the 549 here. So because we're using our unknown as a addend, we have plus 447, and the opposite of it, our inverse, is going to be subtraction. So we've got subtract 447, and we do that to each side, and we get x is equal to $1.02. To check it, we go right back straight up from where we came. We've got $1.02, and we add 447, and we get the 449, okay? So with number 2, we've got 549 minus the unknown amount of savings is going to equal the sale price. So now we've got a positive $5.49, and we're going to take away the amount of the savings, and that's going to give us the sale price. So because this is a positive $5.49, we're going to subtract it from each side of the equal sign, see? So we do, and we get a negative x because this just drops straight down, and $4.47 subtracting $5.49, a larger amount, is going to shove us into the negatives, isn't it? So now we've got a negative x equals negative $1.02. Well, that means that x equals $1.02. We check it. If we had a negative $1.02 and we added $5.49 to it, what would we get? We'd get a positive 447. See? Brought us right back where we were. So for the third one, we are using our unknown amount of savings as the difference, the answer in a subtraction problem. See? So x is equal to this. We just do our subtraction and get our $1.02. We check it. We add the $1.02 to the 447. We get 549. We see it's correctly. So either way, the savings is going to be $1.02. Either way, all the solutions should be the same. But there's different ways to write the equation. See? Can you be open-minded? It's going to help you in the future when you're writing word problem equations. So less than a regular price tells us to subtract, but we can write an equation using addition by adding our variable x to the lesser amount. For problems like this one, our gut reaction is to write a subtraction equation. So keep an open mind to writing an addition equation with the variable x as the addend, okay? So your gut says, oh, this is a subtraction problem. What if it turns out that if you use addition and flip the equation around, it might help you, okay? So be open-minded and keep your sense of humor, but keep open-minded, okay? And make sure you maintain your balance, all right? I'll see you next video. We'll talk about substituting a multiplication equation instead of a division one and vice versa, okay? Bye.